We're going to go ahead and take a look at number 131 from section 7.5, which deals with the review of rational expressions. So 131 reads as x minus 2 all over x squared minus 3x plus 2x minus 1 over x squared plus 3x minus 2 all over x squared minus 9. So the first thing that you might want to do is to note first that you are adding and subtracting fractions. And when you are adding and subtracting fractions, you have to remember that golden rule here that centers all on the denominator. So I'm going to go ahead and rewrite this problem by factoring out the denominators first. So the problem will be rewritten as x minus 2, because again, I'm not worrying about what's going on in the numerator at this point in time. I can factor out an x on the bottom, so that's going to give me x squared minus 3 times x. Now what I want you guys to do is maybe pause the video and continue to work on the denominators. Once you are done, come back to the video and double check your work against mine. As we move forward, we have 2x minus 1 all over, again, there's a common factor of x, so I'm going to pull that out. And then this third term that we have, this x squared minus 9, this denominator, will factor into an x minus 3 times an x plus 3. So recall in class we had kind of talked about how the denominators act like children, especially when we start looking for a common denominator. So we want to make sure that each denominator has exactly the same items or the same factors as the other denominators, because we don't want the children to get cranky. So the common denominator that I'm seeing here, I'm seeing an x, at least in two of them. I'm seeing an x minus 3, and I'm seeing an x plus 3. Those are all the unique factors that I'm seeing. So now I can start going ahead and giving those factors to each term so that everyone has the same denominator. So I'm going to go ahead and rewrite this and give myself a little bit of space to do this. So right now I'm just rewriting the line above that I have in that navy color. And I'm going to come through and note this in a pink. So this first term that I have an x times an x minus 3. He's missing an x plus 3. Now recall that essentially what I'm doing here is I'm multiplying the numerator and the denominator by a glamorized 1, hence an x plus 3 over an x plus 3. If you were just to take that representation or that fraction and reduce it, it would go back to 1. The reason why we're using this glamorized 1 is because I want to just change the outward appearance of the term, but I don't want to change its value. For example, or a simple example, I would never want to take a 2 and make it a 5. Okay, those two numbers are not the same. I want to keep the value of the number the same. Okay, proceeding through, I would then go ahead and multiply the second term by an x minus 3 over an x minus 3, because that is the factor that it's missing. And the third term, I'm missing an x times an x. Okay? So now I can go ahead and rewrite this whole thing, this big monster, under one denominator, because we know that the common denominator is going to be x, an x minus 3, and an x plus 3. Okay, now I have x plus 3 times x minus 2 plus x minus 3 times 2x minus 1 minus a 2x. Okay, you're going to have to do some cleaning up here and some foiling on those first two terms. So this x plus 3 times x minus 2 and this x minus 3 times x minus 1. Again, what I would suggest that you do at this point in the video is pause it and do the work. Okay, foil it out and start combining like terms to see what you get. This way you can kind of come back and see if your work matches with mine. So I'm going to continue to do this. Again, please go ahead and pause the video and make an attempt. So when we FOIL this, the first one we would have x squared then a negative 2x plus 3x minus 6, and then we have a plus. And the nice thing about this is that since this is a plus, I don't have to worry about distributing, unlike if this were a negative sign, because then after I FOILed, I would have to distribute a negative to each of those terms that I got after I FOILed. Okay, so I'm going to go ahead and kind of demonstrate that in this instance. So I'm going to put parentheses around what I'm going to FOIL here, okay, just to explain that point. So this would be x times 2x, so 2x squared, x times negative 1, or negative x, negative 3 times 2x, so negative 6x, and negative 3 times negative 1, positive 3. And then we have that final term of minus 2x. And then again, our denominator stays the same. Okay, so what I'm referring to, and again, when it's addition, it's not that big of a deal, but if this were subtraction, you need to be careful here, okay, because this plus sign is going to each term that you created here. Now, again, in this case, it's a positive 1 times 2x squared. That's just going to be 2x squared. Positive 1 times negative x. That's just a negative x. Anytime that you're multiplying something by 1, you're getting that same number back every time. Okay, positive 1 times negative 6x is negative 6x. Positive 1 times positive 3 is positive 3. Again, this, what I've highlighted out in orange for you, is more important to keep in your back pocket when you are distributing a negative sign or a minus sign. Okay, so really what we have here, again, I'm just going to rewrite this line. So I have x squared minus 2x plus 3x minus 6 plus 2x squared minus x minus 6x plus 3 minus 2x all over that x times x minus 3 times x plus 3. Okay, I need to combine like terms, and hopefully you guys have already done that. So I have an x squared, I have a positive 2x squared, and that's it. So I have a 3x squared. Then I have a negative 2x, negative 2x, negative 6x, and a positive 3x. So that's going to give me negative 7x. Oh, sorry, I forgot him, didn't I? So that's really going to be a negative 8x. Okay, and then I also have a negative 6 and a positive 3, so I have a negative 3. Okay, and again, that is going to be all over x times x minus 3 times x plus 3. Okay, so what you want to notice here is that I do have a trinomial, so I should try to go ahead and factor this. Okay, so to break apart a 3x squared, that would be 3x and x. And let's see what would happen if we did minus 3 plus 1. Okay, again, for the sake of the length of the video, I went ahead and I tried to factor this. So let's go ahead and check the work that we have here. Okay. I'm going to highlight this in pink for you. So 3x times x would give you, I'm going to write my check underneath here. Oops. 3x times x is going to give you 3x squared. 3x times negative 3 is negative 9x. 1 times x is going to give you a positive x, and then 1 times negative 3 is that negative 3. If we combo that, we get that negative 8x. So we did factor this correctly. So what I want you to note here is that I have an x minus 3 in the denominator and an x minus 3 in the numerator. So my final answer is going to be 3x plus 1, and then I have an x and an x plus 3 left in the denominator. So what I have circled there is my final solution. This problem was a bit of a doozy since there were a lot of steps to it, but hopefully you were able to follow. If not, I would suggest going back and rewatching this video. All right.